You've probably heard serotonin called the happy chemical, right? But that simple label, it really hides a much deeper, more complex, and honestly, a way more fascinating story. So today, we're going to peel back that label and look at what serotonin really is, a master architect of the brain itself. And to get it, we've got to go right back to the beginning. To really wrap our heads around serotonin, we have to go back. I mean, way, way back. Before there were brains, before there were even animals, serotonin was already hard at work, inside plants. Now, this isn't just a cool piece of trivia. It's literally the key to everything. It tells us that serotonin's original job had nothing to do with mood. It was about something far more fundamental to life itself.
Okay, so it all starts with this thing called tryptophan, which is the building block for serotonin. Its job in plants was to help capture light. From there, these serotonin-like molecules acted like tiny architects, physically telling the plant how to grow. And that is the absolute key takeaway. From its very origins, serotonin's job was to be a builder, a shaper of physical things. It literally tells cells how to grow, when it's time to mature, and what shape they should take.
So this brings us to the big puzzle, right? If serotonin is just one single molecule, how on earth can it do so many wildly different things? I mean, think about it. Anti-anxiety drugs target it, psychedelics target it, and it's absolutely essential for building a healthy brain from scratch. How can it possibly be all of these things at the exact same time?
Well, the answer is surprisingly simple, but it really changes everything. The molecule itself, serotonin, is just the messenger. Think of it as the key. The real story, the secret, is in all the different locks it can fit into. We call those receptors. And the message that gets delivered depends entirely on which lock that key happens to turn.
And our brain has a lot of different locks. We're talking at least 14 distinct types of serotonin receptors. But for our story today, to really understand this fundamental role in building the brain, we only need to focus on two major players, and they have completely opposite jobs. All right, let's meet our first character. This is the 5-HT1A receptor. For our purposes, just think of it as the force for order, the stabilizer. Its whole job is to create structure, maturity, and calm.
So when serotonin binds to this receptor, its message is loud and clear. Time to grow up. It tells cells to mature, it slams the brakes on cell division, and it physically locks the cell's internal scaffolding, its cytoskeleton, into place. It actually lowers the cell's energy, and clinically, this is the receptor that's linked to reducing anxiety. It brings order, it brings calm.
And it makes perfect sense, right? The stabilizer is the star of the show early in brain development. In us humans, its activity peaks between 16 and 22 weeks of gestation. That's a super critical time when neurons need to stop dividing and settle into their final permanent roles, forming the fundamental architecture of the brain.
But here's the thing. A brain that can only stabilize would never be able to learn or adapt. It needs an opposing force. And that brings us to our second character, the 5-H2A receptor. We're going to call this one the remodeler.
The remodeler's job is the exact polar opposite of the stabilizer's. It encourages cells to divide and grow. It tells neurons to form new connections. Now, to do this, it has to destabilize the cell's internal scaffolding, making it fluid and ready to change. It jacks up the cell's energy, and yeah, clinically, this is the receptor that psychedelics activate to create those hallucinogenic and brain plasticity enhancing effects. It brings change, and it brings new growth. So what you get is this incredible dynamic. On one hand, you have the stabilizer, which is basically the brain's brake pedal, creating order and maturity. And on the other hand, you have the remodeler, which acts as the gas pedal, driving change and plasticity. It's one chemical, serotonin, that can press either pedal, all depending on which receptor it bumps into.
I mean, just looking at them side by side like this, the opposition is just crystal clear at every single level. The stabilizer locks down the cell's structure, pushes it to mature, and lowers its energy, which leads to a state of calm. The remodeler does the exact opposite. It unlocks the structure, promotes new growth, and ramps up cellular energy, which can lead to these profound changes in perception. They are perfect functional opposites.
So, if you've got these two powerful opposing forces, what's actually happening inside the brain? Well, you get a constant, delicate balancing act, a cellular tug-of-war that pretty much defines the state of our mind at any given moment.
And here's the thing. Health isn't about maximizing stability or maximizing plasticity. It's not like one is good and the other is bad. If you have too much brake, you can't learn or adapt. If you have too much gas, you risk instability and chaos. A truly healthy, resilient brain is one that can skillfully, dynamically balance these two forces.
And this tug of war, it isn't just a metaphor. It's a physical reality happening inside our cells. The battleground is the cell cytoskeleton, its internal scaffolding. The stabilizer acts like a construction foreman yelling, "Lock it down," cementing that structure in place. And the remodeler? It's the demolition and renovation expert yelling, "Tear it down," making room for something new.
Okay, so this balance isn't just some abstract biology concept. It has profound real-world consequences for our health, from the very first moments of life all the way to our risk for neurological diseases.
So naturally, we have to ask the big question. What happens when that tug of war gets lopsided? What are the consequences when this delicate, beautiful balance is lost?
The consequences are pretty severe. If the stabilizer is too dominant, the brain could become rigid, unable to learn new things or recover from injury. But if the remodeler runs wild, all that extra energy and instability can actually become toxic, even leading to programmed cell death. Understanding this dynamic is opening up entirely new ways of thinking about mental and neurological disorders.
And we can see this imbalance in action, for real. During development, for instance, prenatal cocaine exposure messes with the stabilizer's job, preventing the brain from building its stable architecture, and the result can be a smaller, improperly formed brain. Then, on the other end, the toxicity of a drug like MDMA, that comes from flooring the gas pedal. The massive overactivation of the remodeler receptor creates a damaging energy buildup in neurons. This isn't theoretical, it's a matter of life and death for our brain cells.
So after all of this, we can see serotonin in a totally new light. It isn't just the happy chemical. It's a versatile, ancient messenger, carrying two opposing instructions in its pocket: stabilize and mature, or remodel and grow. The fate of the cell and the state of our brain all depends on which of those instructions gets delivered.
And that leaves us with a final, kind of fascinating question to chew on. If our brain's very structure is the result of a constant, microscopic tug-of-war between stability and change, all orchestrated by a single molecule, what does that say about our own identity? Who are we really in the middle of that beautiful, dynamic balance?